Straight on that time, not even profile. No, you're good. All right, so let's talk about this empirical rule. It seems to be a pretty important question we have. How to find the possible confounds. Let's actually talk about that first, because we're going to talk about empirical rule and standard deviation and stuff for the most of today. So let's remind ourselves of the ideas with confounding, because you got to know this. First off, confounds are an issue in what type of study?
Experiment?
Yes. Okay. Why are they issues in an experiment?
So they can affect the cause and effect?
Okay, so are issues in experiments? Because what is the goal of an experiment?
Find cause and effect.
So we want an inference about what? Someone already said.
Cause and effect.
Cause and effect. Alright, so let's put this, guys, right here. I'm going to pass this demonstrated understanding back today. I meant to already get it there and I just haven't yet. But we want an inference about cause and effect. And so on the demonstrated understanding from last Friday, I think we took one last Friday, didn't we?
Yeah.
Yeah. Wasn't there the example of listening to classical music?
Yes.
Okay, or not listening to classical music. By the way, listening to classical versus not listening to classical, those were my treatments because that's what the students were told to do, right? That's part of the explanatory. Because what was listening to classical music explaining? It was explaining the, you remember?
This is American.
Yeah, the focus, how much student focus on the test.
It was specifically focused on anxiety. A lot of us talked about the grades on the test, but be careful. There was nothing about the grades on the test in that design. It was about whether listening to classical music would reduce test anxiety. So this is affecting this, so what would I call this variable?
Wait, effect.
It
Or
is,
response.
isn't this explaining the test anxiety, whether you have it or not? So this is my what?
Response.
That's my response, okay. So, we have explanatory, we have response, but here's the thing. Is the only thing that affects test anxiety you listening to music? What else can affect your test anxiety? I gave y'all 3 in the problem, or in the context. But, okay, so the amount of time studying.
Forget.
Okay, so time studying, that can definitely affect your test anxiety. I heard someone say you forgetting stuff,
Yeah.
which a lot of times you forgetting is actually related to your test anxiety, right? So like you stress yourself out to the point that you forget stuff, or you just didn't study enough in the first place. What else can affect your test anxiety? During class, while you're supposed to be, so how you behave in class?
The way you take the situation.
Okay. Does anyone remember I put teacher in there?
The way of
Different ways teachers teach, the way different teachers assess. Now, I want you to notice, I need you to pay attention to this because this is the question y'all had. All of these things can affect test anxiety. But do I care about those things in this study?
No.
So, if these things are affecting the test anxiety, that can affect my understanding of cause and effect, or the cause and effect that I want. That is confounding, right? These variables that I am not interested in are affecting my understanding of cause and effect with the variables I am interested in. That's how you can identify confounding, and that's how you need to talk about confounding, right? Those are the variables that we're not interested in, but can affect my ability to understand cause and effect. Okay? What are your questions about confounding from there? Kate says he's good. Bakari? Making sense? Chris? Yeah, DJ?
Yeah.
Alright. So let's talk about empirical rule a little bit. Which I put myself in a bit of a corner, but it's fine. I will just erase this and I'll put it back later. So first off, what was the empirical rule that we discovered last week?
Those three numbers.
Yeah, what were those three numbers?
0.68.
9.7.
Okay. But what do those numbers mean now? That's a key here. We got to remember, what do these numbers mean?
Those three numbers, three state.
Oh, I have wrote down that.
And like 3% back then.
They are 3% specifically if I'm looking at a distribution, right? Notice, I will point out, what type of distribution does it have to be?
Normal.
Normal. If the distribution's not normal, you know what I cannot use?
The empirical.
I can't use the empirical rule. Empirical rule only works for normal distributions. But if I am looking between, by the way, how do I know that's roughly 1 standard deviation below and 1 above? Remember that point of inflection, right? It's concave down before it, concave up after. So let's say I'm looking between, and by the way, how many standard deviations should I roughly have on either side? 3. Roughly have 3. So let's say I'm looking between 2 below and 2 above. What percent of the data is in between 2 standard deviations below and 2 standard deviations above?
95.
Remember, 1, 2, 3. 95%. Okay? What about if I'm looking only between 1 standard deviation below and above?
68.
68. Notice I'm using my point of inflection. And if I'm looking between 1 below and 1 above, that is roughly 68% of the data. So that's it, right? And we're going to play with halves of these things. Because if I'm only talking about the right side of the distribution, do I have the full 68%?
No.
No, I only have how much of that? Half of 68, 34, right?
Yeah.
And so we're going to use those halves to help us figure out these different details. But the empirical rule at the end of the day is 68% of the data is within 1 standard deviation of the mean. 95% is within 2, and 99.7% is within 3 standard deviations. Okay? We're going to get some practice with finding the percentage in a problem. We're going to work on standard deviation again. Let me ask a question about that in a second. Empirical rule, possible confounds. Is that empirical rule again over there?
Yeah.
Okay, and empirical rule. So, 1, this is the background. How are we feeling about this background?
Yeah.
Ready to use it? Ready to apply it some? So we're going to get some practice with it. Now, in the Kings, y'all said, are we going to work on standard deviation again? What do you mean by that? Do you mean like with this or with interpreting standard deviation?
I don't even know something. I
Okay.
don't have no questions.
Okay. So one thing I will say is do not forget on your assessments, I am also going to ask you to interpret standard deviation. Keep your hands to yourself, please. Interpret standard deviation and mean. Can you please pick that up for me, Maddie? So keep that in mind as well. All right. What questions do you have?
Well,
Yes,
I'm
we
gonna
are.
ask you against my question for number 1, because like at the end of class, you try to find a percentage thing.
Yeah, that's this.
Oh, that's
That's
what
the
that is?
empirical
But
one.
that's easy, because I know, understand.
Now, we're going to have to split it up and break it up in different ways, but let's look at this a little bit more. So, you can go grab a seat. Let's look at the rest of what we got. All right. So, do not forget, we should have our yellow proficiency scales out because that is what literally, by the way, this is Mr. Hobby. He will be with us roughly Monday, Wednesday, Friday for the first half of class. He's in his second to last placement at UA, so he'll have his internship next semester before he becomes a full-time teacher. So make sure you greet Mr. Hobby, get to know him. He's here to help support you. Trying to remember what I was going to say. Oh, but the yellow proficiency scales, that's what I was going to say. Mr. Hobby and I just made, or finished making, the test for my first block because they're already ready. They have a little bit more than y'all do for the test because we aren't quite getting there in this class, and we'll be testing probably Wednesday in here. But literally, we went through and checked and made sure I had everything from the proficiency scale, right?
Sure did.
That's exactly how I made my test. I thought about my demonstrated understanding, I looked at the proficiency scale, I made sure I hit every concept so that you could show me proficiency with those ideas. Yes, Bakari.
I'm turning the camera over there to you.
Sure. Mr. Javi, if you could.
Did you want to do
for me?
it?
Yeah.
Go for it.
Yeah, I like yours.
So, your proficiency scales are
Turn
the
the whole
key
turntable.
to know what to do to be successful and what to study.
Okay.
Y'all's will have a little bit less.
Yeah.
Actually, well, Mr. Javi, can you turn it more towards that? So, they have 13, and then there's 4 vocabulary terms where they have 7 terms, they have to pick 4 of them to define and give examples so that they can show me they understand those terms. Now with that, some of those questions have multiple parts, right? Like where I give you a study, and you tell me what type of study it is, you tell me the population, characteristic of interest, sample, stuff like that, but that's it. And y'all will have less. So, alright. Agenda, I already introduced Mr. Javi. We're going to do the Mathematician Monday, and then we're going to apply the empirical rule, okay? And so, let's look at Mathematician Monday. So, Kaden, can you hit the lights for me, please? So this is Dr. James A.M. Alvarez. One of the things I want y'all to start to pay attention to is, I told y'all from the beginning, I want y'all to be aware that mathematicians are not some just old dusty white dudes that have been dead in Europe for years. Mathematicians are all around you, and anyone and everyone can be a mathematician. And so I want you to be able to see yourself in these spaces. Dr. Alvarez was born in 1955. His mom was a teacher. He was born in Texas, and it's just small details, but it says BAMCO is literally just like a putting together of the name of the manufacturing or the sewage pipe manufacturing company that everyone works for. There's a total of like 200 people, right? So he came from the middle of nowhere. He came from somewhere that was not wealthy or anything like that. He came from a very casual background. Legitimately, they lived 7 family members in a 2-bedroom teacher's cottage, right? That sounds awful to me, because that's 1 bedroom for parents and 1 bedroom for 5 kids, I guess. No running water in their kitchen or anything like that. But I just always want to emphasize, like, he overcame those difficulties. Unlike the last 2 that we talked about, one of the things that is very interesting about Dr. Alvarez is he started out really strong at math. Like, his mom was a teacher. By the time he started, because he sat in the room and watched his mom teach, by the time he started 1st grade, he was actually able to help his mom's like 2nd and 3rd grade math students, and was able to help them learn and things like that, which is different than the ones we've looked at in the past. But one of the things I want to point out that is similar, and something that we can think about this, is the school he ended up going to, right? The school, it says BAMCO, was closed because it was so small, but the school he ended up going to was about 50 to 60% Hispanic, but only 16% of the students in the advanced group were Hispanic. And that's one of the things that kind of bugs me. Like, one of the things I want y'all to like think about and look around you. If you think about the racial...
Can you get Kamaya Tab to the office, please?
She's on her way. If you look at like the racial makeup of Hillcrest High School, what's the breakdown for that? It's what?
What you mean?
Like, what's the racial makeup of Hillcrest High School? What percent? Huh? Little over 50% black folks. It's I want to say 52, 53% black. It's 45-ish% white, and then the rest is Hispanic. Say again. Say that one more time.
Someone that.
We do have a handful of Asians, you are correct. Alright, but here's my problem with that, okay? And this is one of the things that like I want y'all to be cognizant of, and I want y'all to push back on. If we are roughly 50-50, is that what we see in this classroom? No. Why in a regular math class is a majority black students, whereas the school as a whole is 50-50? Those are things that like we need to investigate and ask questions about. Because I can tell you this right here and right now, my black students are just as intelligent as my white students. So why do we have more white students in advanced and honors and fewer black students? I don't have the answer to that. But that is something I want you to think about. There's something I want to challenge with this is anybody can be in that advanced group. It shouldn't be a breakdown where there's a higher percentage of black students than are in the school in grade classes. You're super capable. I would challenge you and encourage you, if you've chosen the easier math classes, try to do something more challenging next year. You're capable of it.
I'm really passionate.
Amber, you ain't barely passed on this. Last year?
Last
But let's not talk, but back up. Let's remember here, and I'm going to talk about this a little bit in a second, okay? Remember last week when I talked about how student grades don't always correlate to what they understand?
Yeah.
That's what that study shows.
Oh, yeah.
So we are going to try to challenge that system where your grade is not reflective of what you understand. Because I've seen you talk and do math at a much higher level than what you're talking about right now. And so I want to encourage you to put in the time and effort to get to that level you're capable of. Just because you struggle in one class doesn't have to define your future. And we're going to talk about that actually with Dr. Alvarez. Okay? So, moving forward with it though, and like heavy discrimination. His sister at their high school, his sister was actually told, even though she's one of the top students up to that point, hey, you should not take any hard classes because you won't be able to do it. His teacher, who now he has a doctorate in mathematics, his teacher told him and all of his other peers, hey, you should not take a calculus class because it's going to be too much for you. And I want you to hear me right here and right now. You'll never hear that from me because you are capable of more. And I'm going to support you in that. And so let's find out how to overcome the past. So when he finished his undergrad in math in 3 years, so first off, traditionally 4-year program, he finished it in 3 years. So is he pretty good at math?
Yeah.
Yep.
We found that out from the beginning, right? Okay, but here's what I want you to notice, right? When he went to grad school to get his PhD, he had to take an undergraduate real analysis course because he didn't get that during his undergrad program. And he felt embarrassed as a PhD student that he was to have to take an undergraduate class. He also went straight from no abstract algebra, which I know that doesn't mean a lot to y'all, but that's a really tough math, and went straight into the second semester of it. And he struggled. And that's because he was missing pieces. This guy ended up getting a PhD in mathematics, but what I want to encourage you and I want you to see yourself in this is your past doesn't have to define you. And sometimes we struggle because we are missing some background information. Sometimes we struggle because we get in our own heads. He started to doubt his intelligence because he was having to take an undergraduate real analysis class. Don't let that be you. I'm telling you here and now, you're capable of it.
Yes.
Let's make it happen, okay?
Yes.
I'll skip that. So, he's focusing now on math education, research, and development. He has a really interesting story of how he became a mathematician, how he became a professor in math education, and so that's why I'm celebrating him today. I really want to emphasize and point out, just because you have one bad experience does not define you. It's how we recover from it and move forward. The dude has a PhD in mathematics, and even he, at one time, after finishing an undergrad degree in math, found himself struggling. And it made him doubt his intelligence, made him doubt his abilities. But he overcame it, and so can you. I'm here to help you become better, become more. Okay? So, any questions before we start with content for today?
No.
Not really?
What
Okay.
concept we gonna be doing next?
Say again.
What kind of concept we gonna be doing?
We're continuing with empirical rule today.
Okay.
Now, we're going to finish the empirical rule today. We may do a demonstrated understanding. We'll review all of tomorrow, and we'll take a test on Wednesday. That's the plan right now, okay? So we need to make sure we're learning this. All right, we already talked about it. Remember, you can go to this tiny URL. You can do the empirical rule in there, 6895, 99.7. Don't forget, you have these check your understanding questions here. Is this where I want to be? All right, the form of norm. All right, so remember I told you, do you have to learn all of these concepts? No. Which ones should you have marked off because we're not doing them? We're not doing z-score. We don't have time. Percentile.
mark off.
And so I took off this one with z-scores and this one with percentiles. And guys, please hear me very clearly on this, okay? Hey, Tyler, come on. Hey,
Do I have that one?
hey, yes, you have that one. Someone asked me for this one. Who was it?
I'm pretty
Amber,
sure
I see you get to. Huh?
Yeah, I'm pretty sure me too.
You don't have the normal distribution one?
I don't think so.
Mr. Hobby, does it say normal distribution on that yellow one right there? Yeah, that one back there? Yeah. Is there just that one? Okay. I'll have to print out another one. Okay. All right. Okay. Really quickly. So, one thing I do want to point out is, the only reason why we're not doing those is not because you're not capable, it's just we're running out of time. Right? I can't spend forever on normal distributions. We're just running out of time, so we got to move. Say again? Okay. So all of this in the textbook, remember, it's just to help us get to that empirical rule that we already did. Does anyone remember the difference between a standard normal distribution and a normal? Standard normal versus just normal.
Oh, the standard you gotta find like the percentage and shade it in, and normal you just gotta.
So you can actually do those percentages with both standard normal and normal. So let's say this. Let's say that the height of all 8-year-old girls in a school district has a mean of 50.
It's not normal.
Why not?
So it's skewed right.
Is it? Is it pretty close though?
No.
I'm not a perfect drawer. Okay? So I want you to notice here, this is a roughly or approximately normal distribution. And what's the mean in this case? 50. And what's the standard deviation? It's about 2.5. I know that because of the what? Point of inflection. There we go. But this is a normal distribution. 50, 52.5, 55, 57.5. Okay? But if I were to take these values out and make this 0, 1, 2, 3, this would be standard normal. Why is this now standard normal? Mean of 0 and not just the negative. What's the standard deviation? 1.
Oh.
See how the standard deviation is 1 now? So if the mean is 0, the standard deviation is 1, that's the standard normal distribution. Does it matter which one I use to use the empirical rule? No. Okay, so I just want to remind you of that. And I believe where we ended, which of these did we do on Friday?
I think A and B only.
A and B only? Okay. So to get us into you doing some practice on your own, what percent of the data is greater than the mean? So remember I shade all this. What percent was that? 50%? It's literally half of the data. What page is this, by the way? We should probably go ahead and get this out.
M525.
M5-25, thank you. We're about to use this, so I would go ahead and get it out. So M5-25.
Right. They should go to the paper. Yep.
Okay.
Mr. Ken, maybe you can keep more, like what I'm talking about, when it says like the second standard deviation or like stuff like that, I'm trying to figure out how we figure that out.
We're about to do B, and then y'all are going to work.
Okay. Thank you.
Okay. So, oh no, we got to find that paper. M5-25. Okay, let me go over this. Hey guys, let me go over this B. Let me go over this B, and then I'll support you. Mr. Hobby will support you. We'll try to find those papers. Right here, though, what is B asking me? Percent of data that is between the
Mean.
So I'm gonna mark my mean and what? Boom. 2 standard deviations here. Below, right? So it needs to be negative. And so I want all of this. Okay? So how did we find this last Friday? We just guessed?
Yo.
Looked at it, came up with something?
It's gonna be 95.
Okay, so remember we got our empirical rule.
Oh, we go.
Now, hold on. Jamie, J Mike said something about 95%. Why is he saying anything about 95%?
Because that's the second deviation.
So when we're talking about 2 standard deviations, we're looking at 95%, right?
Yeah.
Dawn, were you about to push back on that though?
Oh no, I was gonna put forward on it.
Do what?
I was gonna put forward on it. I thought you was asking like how we got the what you call it. I forgot what he got. He
Okay.
said something about dividing it.
Wait, we need to divide something?
Yeah.
So it's not just 95?
No.
you got divided by half.
Let's be careful. Okay, so let's be careful with our language. Are we dividing it by half or are we dividing it by 2?
Divided by 2.
Divided by 2. So let's look at it. Remember, 95 is all the way from -2 all the way up to 2.
Yes.
How much of that 95 do we have though? We have half of it. So technically, and I just want to show you this, if I were to divide by a half, that would actually end up multiplying it by the reciprocal. Do I want to double that number though? No. You can either do half of 95, literally 1/2 of 95,
Yeah.
or 95 divided by 2 gives you 47.5. Huh? Okay. Either way. So we should already have this as 47.5.
That's how we do it.
Yep, that's a part of it. Now, this is what we finished on Friday, right? This is what we finished on with Friday?
Yeah, we finished on
Okay. So at this point, oh, we finished with A on Friday?
Yeah.
Whoopsies. Sorry, I jumped y'all in. Okay, so some of us did B, some of us didn't. Now we're all on the same page though, right?
Yeah.
So what I want us to do is, I want us to actively collaborate, help each other, figure out C and D on the vertical surfaces. Mr. Hobby and I will be coming around, giving you feedback, stuff like that, alright? So let's get after it. What? Okay. Did you ever find this page? Yeah?
Oh, yeah, I already got it. It was.
So if I were you, I would make sure that I put everything in order.
No,
like
I know what it
this.
means. I can just do my
Don't you notice something about part B when you did here?
Wow, you were falling asleep on me.
Picture stops at negative 2
Yeah, because you tried to fall asleep on me. I ain't trying to fall asleep. Let's go.
Tired.
Learn something. Hey, by the way, guys, vertical surfaces. I want y'all collaborating. But into the center of the room. Into the center of the room. All right. Kaden, is there a red light flashing over there?
Yes.
Cool.
It says
All right.
access.
So, I need y'all to notice this, right here, eyes and ears, because this is an important idea. It's going to help us be successful long term. So, why was I able to take half of 95% to get that 47.5?
Yeah, why?
Yeah, why was I able to do it? But why was I able to divide it?
Oh, because it wasn't the whole thing.
Yeah, but like, so I can just do it, I can just take half whenever I want?
No, let's take half and a half.
That's what the question asked.
But how do you know you can do half? Why is it not a third? Why is it not a fourth? Why is it not 3 halves?
That's not what
Because
it asked.
that's not what it is.
But how do we know?
Because of the
Because
two
only half of
sections.
it is shaded, sir.
Only one
Half of
side
what?
shaded. Only one side.
Okay, only one side. What do you know about this brown region and this pink region?
They're equal to 95%.
They add up to be 95%, but there's something else. Do those look the same or do they look different? Okay, remember one of the keys of a normal distribution is that it is what? There's two features of a normal distribution. Symmetrical and
Binomial? I mean,
unimodal. Okay. So it is symmetrical, right? So what do I know about this piece and this piece? They are even. They are the same or equal. So why can I do half of? Because
It's half.
they are
Equal, right?
the same, right? And when I say they, really I should clarify it, because -2 to 0 and 0 to 2 are the same, right? It's the same percent of the data, right?
Yep.
I can visually see those areas are the same. Thank you. Hey, Preston and Tyler, right here, because that's an assessment. We'll talk about that later. I need us learning right now.
Mr. Kenny, where did Mr. Harvey go?
Remember I said he's only going to be here through the first half of class because he has to go to 2 classes at UA. All right, so let's come back down here, and I want to talk about this one. Because a lot of us were recognizing, how much do I have in this brown region right here?
35.
In the brown that I just circled. I still have 47.5. Isn't that half of 95 again?
Yo.
Okay, so from -2 to 2, which remember you're negative, that's 95%. And so I have half of that 95%, which is 47.5. And one group, and I totally get this, I want us to learn from this. One group took that 47.5 and divided it by 2. However, I want you to look at these. Are these the same?
Nowhere near the same.
You see how that's bigger than this? So I cannot, listen, I can only do halves when I'm looking at symmetrical pieces. Well, I was talking about with this group, notice I have half of 95, but I don't want this piece. So, mathematically, John, what operation allows me to get rid of something I don't want? Subtraction, right? So I don't want this piece. Does anyone know how I can find what this piece is, though?
Yeah.
By looking at it.
65.
Wait.
It's half of what?
One.
Well, it's 1 standard deviation, so it's half of 68%.
35.
So all the way from 0 to 2 is half of 95%, right? Now I need to get rid of half of 68%, which is 34. Which I want you to look at it. Is this smaller than this piece? Like you can see it visually. That section is smaller. Okay? So, please remember the only time that I can do half of is when they are symmetrical. When these pieces are the same. But when I'm trying to get rid of this piece, it's not the same. So I need to figure out how much that is and take it away. So when we want to take away something, Amber, what operation do we use? Come on, in math, when we want to take something away, what operation?
Subtract.
We subtract, there we go.
Yeah.
Right? So I found half of my 68, 34. So I know this region is 34%. And I take it away. That's it. What are your questions before we continue to practice with this?
So,
47.5 minus 34. Yes.
Obviously, I still need most of that. That was the bill what you were saying.
Hold on.
I was kind of confused what you were saying about all this stuff.
Okay, I'll come in and check it on you in a second. Is there anyone else still confused that I need to talk about right now?
You didn't do another problem like that, because sir, doing it one time, don't help sir.
Well, madam, I plan on doing a couple of them.
Okay. Feel like that?
They're like still in the book, you know? And there are check your understanding questions. Look, right here. Hey, I know that if I am dealing with 2, I'm dealing with, if I'm dealing with 2 standard deviations, which of these numbers am I dealing with?
95.
95. So everything from 0 to 2, all of that area is at 47.5. It's half of the 95. Okay? But I don't want this region. Are you looking actually here while I'm talking about it? I don't want this region. Well, what standard deviation is that region associated with? Well, what number is associated with 1? So half of 68 is,
Oh, that's how we got.
so that's how I got 34. So I had 47.5, but I needed to get rid of 34, get it out of there, so I just subtracted. The area that's left is 13.5%. Okay? Now, I know someone's gonna be like, Mr. Kenny, I need more practice. Mr. Kenny, I'm not 100% there yet. That's okay. You're in groups of 3 for a reason. We're gonna go back, we're gonna work on D, and then we're gonna work on some more. So I want you to go work within your groups, talk with each other. I'll be coming around to support you. We'll come back and we'll discuss. Let's get after it. Chelsea, does that make sense now? Okay, so you see why we can't just do half of half?
I don't know why you.
Okay, you always have Alexis Preston.
You have no.
So we can't just split it in half again. Yes,
I don't
Picard.
use it all. I'm not gonna get all the time, but I want.
Couple of minutes to just make some notes to yourself, but I want us to notice 2 things. There's actually multiple ways to do this. Okay? Yeah, multiple. Okay? So I'm going to show you the way I would have approached it first. Then I'm going to show you the way that Mel did it, and in another way that is actually a good idea based on what Mel was thinking. Okay? So, right here. I need y'all to remember. What's the empirical rule? What's the numbers?
68, 95, and 99.7.
Okay. But remember, 68% is from 1 below to 1 above.
Right.
95 is from 2 below to 2 above. 99.7 is 3 below to 3 above. But what if I go beyond 3 below to 3 above? What if I go all the way from here, all the way to here? What percent do you have? 100? You got the whole thing. I need y'all to remember that. Then I need y'all to also remember the idea of symmetry. So when I'm looking at D and it says from 2 below to everything above. Hey guys, what percent of my data is to the right of the mean?
50.
That's 50% right there.
Yes.
It's freaking the other one.
And what's this part?
Yes.
Well, we're going to the -2. Now, 95 was from -2 to 2.
47.5.
We only have half of that 95, don't we?
Yep.
So remember, when we're only dealing with a side around the mean, it's half of it. So this is 47.5. Then what am I going to do with those 2 numbers? I'm going to add them together.
Oh my God.
Okay. Gotta keep that in mind.
That's nice.
Now, Mel, what did you, and so that's 97.5, right, total. Mel, what did you do though?
I looked at the 95%,
Okay?
and then I
So-
figured it'd be 5.
Hold on, let me erase this. So you just looked from the 2 below to 2 above, right? And you knew, hey, that's 95%. Now what?
And then you know that there's 5% left, so there'd be half of 5
So,
on one side and half of 5 on the
Looking at these 2 tails, right? If 95% is in the center, what is the total between these 2 tails? No, the total just in the tails.
Oh.
It's 100 minus 95, or that's what Mel said, right? 5%?
Yeah.
So Mel, you knew how much was in just one tail?
Yes.
How much?
2.5.
Because isn't there symmetry, guys?
Yeah.
It's the same amount?
Yep.
So what's 95 plus 2.5? 97.5.
And now for now.
Oh. Using Mel's logic as well, watch this. What has to be in this tail?
2.5.
2.5, right? Using that same logic. And what's the whole curve? What percent? 100%, but I don't want how much? Wait, so if I take 100 and I subtract 2.5, what do I get?
97.5.
Now, the method I personally always like to do is to take the halves and add them together. But is there way more than one way to do it?
Yep.
Would Mel get 100% credit for doing it that way?
Yep.
Would you get credit for seeing it this way? As long as you show me evidence of understanding. So we have about 2 minutes left. If you need to grab your phone and take a picture so that you can do notes to your future beautiful self later, do that. I would do some check your understanding based on, hey guys, you should have everything you need for check your understanding. We will have a demonstrate your understanding tomorrow and then review for the test. You also have your study design stuff back, so make sure you study that and know what questions you need to ask for that. Samaya, that's yours? Yes, that's what I'm literally looking for you right now.
She don't sit over there, look right. You come back here.
Hey, Amaya and Cameron, here's some papers for y'all. Amaya's paper and graded it. Just got Mr. Kenny all the time. Addison, Samaya didn't come back, did she?
No, she checked out.
So guys, what should you do tonight? Check your understanding. Check your understanding. Listen, hey, I do want to say, excuse me, I'm talking. I do want to encourage y'all, you did do significantly better after we had that conversation. But don't forget, you are always capable of more. So let's make sure we're putting in the time and effort to get to that more. Check your understanding. I might let you ask some questions before we start class tomorrow. Queens. Kings.
Mr.
Fours. Yeah.
I'm leaving your pencil on the
Thank you.
No, I'm taking.